Everybody, thanks for coming today. Sorry, my voice is a little shot, but I'll do my best. We'll do about 30 minutes today. As you know, number properties is a very, very large topic, so there's a lot that can be covered. As you probably also know, things shifted a bit with GMAT Focus as number properties is concerned. You know, some of the stuff I really liked to go over was a lot of like pure math with divisibility, with remainders. But, you know, what I've actually noticed is they've shifted a lot of those and they've just turned them into word problems. So one of the things you'll notice in TTP, and I don't know if we've updated it yet, but the divisibility section, we did a lot to it because, like, you know, word problems can test the same stuff that pure math used to. So it's just something to keep in mind. Today, we'll do some things with trailing zeros, maybe some divisibility with factorials, and then kind of call it a day. So as always, I'll put some questions up. You guys put the answers in the chat box, and then we'll go from there. All right, so first question is this here. All right, so looks like most of you guys got this right. So for anyone who use TTP, you know that we do a lot with trailing zeros. So the idea to figure out how many zeros there are at the end of a number has to do with how many 5-2 pairs there are in the prime factorization, right? So when you simplify this, you're left with 25 by 24 by 23 by 22 by 21. And you could break all of these into primes, but you could also recognize that there's way less 5s than 2s within that string of numbers if you were to prime everything out. So because 25 is equal to 5 squared, that's enough to say, okay, well, there's 2 5s. There's going to be more than 2 2s, but that means the trailing zeros are going to max out at 2 of them. And that's why the answer here is C. All right, let's keep moving now. This same concept can be used for digits. So take a look at this here. All right, so did you guys use the trailing zero rule first to figure out the number of zeros in this string of multiplication? I mean, I assume the answer is yes. Okay. So yes, that is always step one when dealing with digits. Because what I will tell you is nobody on the GMAT is actually expecting you to do this math out. There's no number containing 19 digits, which we know is the answer that they're going to expect you to do the math for. So what you do is you break it down. So you do 50 to the 8, right? Now that becomes 5 squared times 2 to the 1 to the 8, 5 to the 16 times 2 to the 8. Then you have 8 to the third, which as we know is 2 to the third. So that's 2 to the third to the third. That's 2 to the 9. And you have 11 to the 2. Doing this out, 5 to the 16 times 2 to the 17 times 11 to the 2. So you look at these and you say, okay, we have 16 zeros, right? Then you say, well, what's left over? Well, what's left over is 2 to the 1 times 11 to the 2. Now you could do this out, or you could say, you know what? That's just going to be 3 digits. You take 16 zeros plus 3 digits. 19 digits is your answer. That's how you deal with that. All right, so let's keep this going. And next, well, this is an interesting question here. I just want to do it out real quick. Just to kind of put a bow on all this. So take a look at this here. All right, so was this an easy, I mean, seems like this was an easy answer. My question that I kind of have is like, if we weren't doing these questions and let's say you just randomly got this, would this been just as easy? And what about if the answer choices had a different number? Well, right, but I'm saying if we weren't doing the exercises. Oh, yeah, exactly. Now, what about if the answer choices were a little different? Let's say this was 0, 0, 0. Let's say this was 1, 1, 0. Like, at that point, would have it been more challenging? Because then you would have to figure out the number of zeros and not just that it ends in a 0. Yeah. But the good news is it's not difficult to do it because remember, you can use factorial divisibility rules to figure out the number of zeros, which we'll talk about in a second. Because what these factorial divisibility rules do is they tell you how many primes are in a certain factorial. And that's a huge thing with factorial trailing zero questions, which we'll get to in a moment. But first, I want to do just a very straightforward one that's just testing on plain divisibility. All right, so take a look at, oops, why is this not, there you go, this one here. There is no solution here. Any factorial greater than 4 factorial ends in a 0. So that's the solution. That's why A is correct. All right, do this one out here. All right, so are you guys aware of the, no, we're not going to talk about terminating decimals today. Are you guys aware of the rule with factorial divisibility, how you determine how many 7s are contained in 100 factorial? Okay, so one option is you just break down 100 factorial and you look at the multiples of 7 and you count. And that's doable in some cases, but also unnecessary. So the mode of doing this is you take 100 and you care about the number of 7s. So you say, okay, I'm going to divide by 7 to the 1. Now, when you do that out, you get 14. There's some remainder, but we don't care what the remainder is. We care about the quotient. And then you go up a level and you say, okay, well, what about 7 to the 2? Now, 7 to the 2 is 49. 49 goes into 100 twice with some remainder, but again, we don't care about the remainder. We just care about the quotient. And then you're going to see that 7 to the 3 goes into 100 actually 0 times. So we stop at that. We add together the quotients, and that's our answer for how many 7s there are in 100 factorial. So these can get a little bit more complicated, for example, and then I want to show you how they relate back to trailing zeros too. Give me a sec here. So for example, take a look at this. All right, take a stab at this one. All right, so here's the deal with this problem, and here's also why many of you got this wrong, or not many of you, some of you. This only works for primes. It doesn't work for regular non-composite numbers. So what you have to do is you have to ask yourself, okay, in order for something to be divisible by 6, we know it has to be divisible by a 3 and a 2. If you look at a factorial, we know that there's way less 3s than 2s in that factorial, right? And if you're asking yourself why, it's because there's less 3s than 2s in any string of consecutive integers, right? Because 3s come every 3 numbers, 2s come every 2 numbers. So with that said, we really just care about the number of 3s and not the number of 2s, right? So we take 30, we divide it by 3. We do the same thing. We take 30, we divide it by 9. That's going to give us 3. And we take 30, we divide it by 3 to the 3, which is going to be 1. And then you add those together. Any questions about that? And yes, it's because 6 is not a prime. Well, you can consider the 2s, right? You can consider the 2s, but the thing is, there's going to be more than 14 2s. So you probably are going to have like 20-something 2s. It's still, the limiting thing is the number of 3s. So you could do out how many 2s there are, but it's not going to matter. It's not going to change the answer. Does that make sense? Just let me know if that makes sense. No, you look for the bigger value. You look for the bigger prime, which is going to have a quantity that's the less of, right? So yeah, I mean, more or less, that's the. Yeah, exactly. It's similar to the 5-2. Exactly. It's exactly like the 5-2 pair rule, except you're dealing it with 6s. And remember, not every number has this clean-cut divisibility thing where there's 2 numbers that you need to make it work, but you know, there's enough here in this one with 6 where this is a logical way to deal with this. So, yeah, so that's it. So we can stop here. I mean, this is a pretty cool rule. And it's very useful. You can use it for trailing zeros. If you guys are in our course, we have some great lessons on it within number properties. And yeah, so does anyone have any questions before we log off? Any random, you know, GMAT related questions, TTP questions, etc.? Any questions at all? I don't know. I mean, prime factorization in general is an important concept because it, you know, it utilizes, it's necessary in a lot of things when you're talking about factors, when you're talking about LCM and GCF. I don't think that, yeah, I mean, it's all important because the thing is, if you know how to do prime factorization, but you don't know how to do something else, you're still not getting the question right. So yeah, I mean, that's really the deal. So, any other questions? I would follow the TTP study plan the way it's laid out. We don't have a 3-week course. To be honest, though, I don't know if we'd even feel comfortable giving one. You know, we like to do things that we think are most helpful for students, and knowing the GMAT the way I know the GMAT, I don't see how anyone's going to get anything out of a 3-week course. Any other questions? I think a few months for DI, but if you've learned Quant and Verbal first, that's going to be a big help. Yep. Any other questions? All right. Well, if that's it, thank you everybody for coming. Hope you enjoyed a thing or two. Hopefully my voice will be back by next week. Fingers crossed. Have a good weekend. I'll talk to everybody soon.